So we're back at Falstad. Just again, not something you really need to know about digital logic, but to help convince you that yes, we can build these things together in using transistors in real circuits. This is how computers work, and you know that, but it helps to see it. All right, so I'm going to start out with opening from a file, and I'm going to go the simple TTL buffer. Okay, so the same logic circuits that we saw last time, now we're going to see them in actual circuit form. Okay, so this is the buffer. As long as the input is, and by the way, the input is driven from the same power in this case as the rest of the system, but that doesn't necessarily have to be the case. It could have its own power. But either way, I'm using a switch here to turn it on or off. Okay, so as long as A is on, the output A is on. And when I shut the input A off, the output A is off. So that's just the buffer. So the buffer, like I said, is a real circuit. By the way, this is called TTL, or transistor-transistor logic. It's also known as RTL, resistor-transistor logic, because resistors are used to help modify what's going on with the transistor. Okay? There is another kind of logic, and we'll have a quick look at that before we're done here. All right, the next one we're going to look at, open file, we're going to go look at the simple TTL not. There it is. Okay. And it looks very similar to the input, but it works differently. Notice that it is not, okay, even though A is on, our output LED is off. And so if I switch that, now the LED comes on. And it's using a property of path of least resistance to ground. Okay. And so right now there's a huge resistance going to ground here, but there's not so much resistance going here. Even though this is a diode that has a little resistance to it, there's more resistance across this transistor. And so when this transistor is not being powered, it's not allowing any current to go through. And so the current has to go through here to the output, as opposed to here when it's powered. And now it's allowing current to go through, which has less resistance than this diode, this LED. Okay, so that's the NOT gate. Let's look at the next one. Okay, so open file, we're going to look at the TTL AND. Okay, and there it is. Okay, it's simply two buffers kind of in series. Okay, so if either one is knocked off, it stops the flow through to the LED. It's not perfect. There is still a little bit of flow. Let's see if I can find it. There it is. Okay, 376 picoamps. Okay. But it's not enough to light that LED. And so low is good enough for 0 in this case. Okay. So that's the AND. If they're both on, it's on. If either or both are off, then it's off. Okay. And then the last one we're going to look at is the OR. And the OR looks a little bit like the NOT, and it works kind of the same way, except now we have our two transistor gates in parallel. Okay, so that if either one is on, it gives it a path through to that LED. And that's how that's working. Okay, without that, there is no path from the input to the LED. And so the LED does not light up. Okay, and notice you've seen this a few times, when I hover over the LED, it gives me the symbol for a diode, because that's what it is. It is a light emitting diode. Okay, so if either of these are on, then the light's on. But if they're both off, the light's off, and that's the definition of OR. So we can create those gates using transistors. Very cool. Okay. I'm going to show you another one of Faltad's very own. So circuit examples. We come down here. And by the way, if you're interested in all this stuff, Falstad is a wonderful place to find stuff. And so they have RTL NAND. NAND is just the opposite. It's an AND with a NOT. And so you see if everything is true or high, then the output is low. But if any of these go to high, if any of these go to low, the output goes to high. If they're all high. And notice that there are 3 inputs this time instead of just 2. This is going to be a property of gates that we're going to talk about in the next time. Okay. So that is also RTL, but there's another version, DTL, and it looks a little bit different. Uses only one transistor and a few diodes to accomplish the same thing, and so it's a little more efficient. Okay, but it's essentially the same idea, and so that's a different kind of way to create these circuits, but it works the same way. So you have now seen that we can create circuits using diodes, resistors, and transistors to do the job of Boolean gates. In the next video, we're going to talk a little bit more about those gates and how they work together. Okay. See you then.